Alright, hello, welcome. In this video, I'm going to be working Algebra 2 Homework 9.4. And so we're going to be solving some exponential and log equations here. And so I think really the thing that we need to remember is we got to be fair to both sides. And to get rid of a log, we need to, take some number to both sides power. And if we're trying to get rid of an exponential, we need to use a log. Okay, that's going to be really important. So I'm going to get out a separate sheet of paper like you should do. Because I'm not going to take that original sheet of paper from you. That won't be good enough. So 1a, log base 4 of x plus 5 equals 3/2. Okay. So I'm going to take 4 to both sides power. Okay. And this will give me x plus 5 on the left side. And on the right side, I'll have 4 to the 3/2. So I'm going to take the square root of 4, and that's 2. I'll take that to the third power. I'll have 8. I'll subtract 5 from both sides, and I'll get x equals 3. Okay. For 1b, I'll be taking the log with base 5 of x minus 6, and that will equal 3. Okay. So I'm going to take 5 to both sides power. Okay. 5 to the third is 125. And on the left side, that will cancel off, and I'll have x minus 6. So x minus 6 equals 125. Add 6 to both sides, and x will equal 131. Okay, for C, I'll have log base 6 of x minus 4. That's going to equal 2. So I'm going to take 6 to both sides power, because the base of the log needs to be the base of the exponential. So 6 to the log base 6 of x minus 4 equals 6 to the 2. So that's going to be 36 here. I'll have x minus 4 over here. I'll add 4 to both sides, and I'll get x equals 40. The next one, I get the feeling I'm going to need some more paper. Okay, for 1D, okay, I've got 2 logs, so I'm going to need to use a property. So log base 2 of x minus 7 plus log base 2 of x equals 3. Okay. So I'm adding 2 logs. I can multiply their their arguments. So x minus 7 times x would be x squared minus 7x. That's going to equal 3. Now I'm going to take 2 to both sides power. Whoa. Okay. So I'll have x squared minus 7x equals 8. Okay. I've got 2 different powers of x in the same equation. That means I have to set it equal to 0 in order to solve. So x squared minus 7x minus 8 equals 0. I think I can factor this. 2 numbers that multiply to negative 8 while adding to negative 7 would be negative 8 and positive 1. So I'm going to say x minus 8 times x plus 1 equals 0. And I would get x equals 8 and x equals negative 1. But I got to check my answer here because extraneous solutions can happen, especially when you end up, like with a quadratic or something. If I plug in x equals negative 1, this is going to be bad news, right? Because I'll have log base 2 of negative 8 plus log base 2 of negative 1. Neither of those things are well defined, so I'm not going to be able to add those up to get 3. Right? It's not going to work. So I'm going to cross through that one. That one's an extraneous solution. I'm going to move on. All right, for E. 2 natural log x plus 3 equals 4. Okay, and if you don't see it, it's implied that the parentheses goes around the x. And so I need to kind of isolate this log before taking e to both sides power. Okay, so I'm going to subtract 3. So 2 natural log of x equals 1. Means natural log of x equals 1/2. And now to get rid of the natural log, I need to take e to both sides. So I'm going to say e to the natural log x equals e/2. E to the natural log x, that just is x, and that's e to the 1/2. You could write it as e to the 1/2 if you want. I might just say that's the square root of e, just to remind you that those are the same thing. Okay, for F, I've got common log, so I'm going to actually write base 10 log there. 2x plus 10 equals 3. Okay, so I need to take 10 to both sides power to get rid of this log. So 10 to the log base 10 of 2x plus 10 equals 10 to the third. And yeah, that means that 2x plus 10 equals 10 to the third, which is 1,000. 2x equals 990, meaning 1x is going to be 400, not 50. Hold on, I'm going to have to think about this. So it would be 450. Wait, why am I struggling here? It's going to be really close to 500. It's going to be not 490, it would be 495. Think about that. Yeah, that's true. Because half of 900 is 450, and half of 90 is 45. That's why. X is 495. Okay, for 1g, natural log of 1 minus x equals 1. So I'm going to take e to both sides power to get rid of this x, to get rid of this log. Okay. So 1 minus x equals e. Right, so maybe I'll add x to both sides. I don't usually do that. 1 equals e plus x, and we're solving for x, so x, I'm going to subtract an e from both sides, and I get x equals 1 minus e. Okay. And that's an exact solution, right? It did say, yeah, give an exact value. Okay. An approximate answer would be if I made e 2.718, whatever, got this as a decimal. Okay, for h, I am 1 minus 2 times the log base 10 of x. That's equal to 3. Right, and so I'm going to subtract 1 from both sides. And I'd get negative 2 times log base 10 of x is equal to 2, meaning log base 10 of x equals negative 1. And log equals a negative number, that's not a problem. It's when we're taking the log of a negative number that we run into an issue. And so I'm going to take 10 to both sides power, or I can just say, okay, x is going to be 10 to the negative 1. Okay, if you're to that point where you're just seeing that, that's fine. Okay, but if you're not, just stick to the properties and the fundamental identities. Okay, so x is going to equal 10 to the negative 1. That's 1 over 10. For 1i, let's see what we got here. Log base 4 of x squared equals negative 1/2. Interesting. Okay. Well, I'm going to take 4 to both sides power. Makes me wonder what I was thinking here. Oh, I see where we're going here. All right, so this is x squared on the left. On the right, this is going to be, the negative power is going to be 1 over 4 to the 1/2 power, 1 over the square root of 4, 1 over 2. So x is going to equal plus or minus the square root of 1/2. Okay? And either one of these we're working on to worry about an extraneous solution because I'm squaring first before taking the log. So if I square either one of these things, I'm going to get 1/2. And that's a positive number. So I'm thinking, and maybe I'll write this in simplified radical form, plus or minus root 2 over 2. That's as much as I can do with that one. All right, so I'm going to need significantly more scratch paper. Difference. Oh, that was a huge stack of retests in there from last semester. That's not good. All right, so 1j. All right, log base 2 of x to the 3 plus x to the 2 minus 4x, I know where this one's going, equals 2. I had realized it had been too long since we'd done group and factoring. That's been one of like the big things we've learned how to do in this class. We've done it repeatedly. So it's like, well, I'm just going to find a way to make them do it now. So we go over here, and we're going to take 2 to both sides power to get rid of this log. So 2 to the log base 2 of x to the 3 plus x to the 2 minus 4x, that's going to equal 2 to the 2. And, okay, so that means that x to the 3 plus x squared minus 4x is equal to 2 squared, that's 4. And because I've got multiple powers of x in the same equation, I have to set it to 0. Okay, and now I'm going to do group and factor. So I think out of the first 2 terms, I can pull out an x squared, leave me with an x plus 1. And then out of the second 2, I can factor out a negative 4. and I'd be left with an x and a plus 1. Okay, so that leaves me with x squared minus 4 multiplied by x plus 1 equaling 0. Keep going here, x plus 2, x minus 2, x plus 1 equaling 0. Okay, and so that's going to give me x equaling -2, 2, or -1. But I need to check these, make sure that's not causing me to take the log of a negative number. So I'm going to plug in -2. I'll have -8 plus 4 plus 8. Okay, that's fine, right? I'm taking the log of a positive number. When x is 2, I've got 8 plus 4 is 12 minus 8 is 4. Okay, we're good. I probably should be pointing back at this one, but I can't fit them both in. When x is -1, I'm going to have -1 plus 1 is 0 plus 4. Okay, so all three of these are valid. None of these were extraneous, but you do need to check. And that's all for number 1. Okay, so for number 2, we're going to solve an exponential equation by taking out a log of both sides. Maybe it's natural, maybe it's not. So 2a, 40 equals 3 times 2 to the x minus 5. Okay. And it wants an exact value, which hopefully at a certain point you'll come to appreciate the ones that ask for an exact value actually take you less time. Because the ones that have an approximate value, you find the exact value and then you type that into the calculator, or you go look up something from a table on numbers 3 and 4, and it just takes more time. So exact value actually lessens our level of responsibility. 45 is 3 times 2 to the x. Okay. I'm trying to access this 2 to the x, get it isolated on its own, so I have to get rid of that 5 and that 3. So I'm going to divide both sides by 3. 45 divided by 3 is 15, and that's 2 to the x. Okay, if I want to get this x down out of an exponent, I need to take the log with base 2 of both sides. Okay, so I'm going to take a log base 2 of 15, and that's going to be equal to log base 2 of 2 to the x. Okay, that's just going to be equal to x. So x is log base 2 of 15. Okay, that's an exact value. Let's move on. Okay, and b, that might have been it. Nope, that's not going to be too ambitious. 3 to the x plus 1 equals 9. Okay, trying to get at that 3 to the x, so I'm going to subtract 1 from both sides. Okay, now that I've got it here, I don't really have anything else to do besides just say log base 3 of both sides. Try to get that variable down out of the exponent. This will give me x, and that'll be log base 3 of 8. Okay? That's not going to be a good number. I know log base 3 of 9 is 2, log base 3 of 3 is 1 and 2, but I'd need more information to determine that more accurately than it's between 1 and 2. All right, 2c. That's 2e to the 3x plus 4 equaling 7. Okay, so I got to get that e to the 3x by itself, and then I'll take a natural log of both sides. So I need to subtract that 4 first. 7 minus 4 would be 3. Divide by 2. Okay. Take the natural log of both sides to get rid of that e. Okay. And what else was I going to say here? Oh, while a person could definitely say this is natural log 3 minus natural log 2, that's not going to be any more exact or any more proper, so I'm not. Okay? This is going to be 3x equals natural log of 3/2, and I'm going to solve for x by dividing both sides by 3. 1/3 of the log of 3/2, or 1.5, whatever you want to call it. Okay, that was 2c. 2d is 3 times 10 to the x equals 18. Okay, so I need to isolate the 10 to the x, so I'll divide by 3. 10 to the x is 18 divided by 3, that'd be 6. I need to take the common log of both sides, the base 10 log. It'll give me x on the left side and log base 10 of 6 on the right side. That's not something we have a table for on this homework, but I think you've seen a table of values for common log. You can look it up, use a calculator, or you could just not, right? Ask for an exact value. Let's just walk away. So 2e. 3 to the 1 minus 2x equals 4 to the x. Okay, this one is just sitting there right in the middle of the homework, and this one's kind of tough. Okay, my recommendation is that when you have, what's saying here? When you have different bases, just take the natural log of both sides, and then use an exponent or use a log property. Okay, and this is one of those that I'm going to slip in there on the homework. And I'm not going to just slip in there on the quiz or the test. This is really for your own benefit and development. This is the type of equation I think we will solve more in pre-calculus next year. But so I'm going to start by taking the natural log of both sides. Okay, and then I'm going to bring these exponents around the front. So I'm going to have 1 minus 2x times the natural log of 3 equaling x times the natural log of 4. Okay. Now, I think there's not really much else to do besides you need to realize that natural log of 3, it's just some number. It's not really like something that's worth being scared of. So I'm going to distribute that over here. So I'm going to have 1 times natural log of 3 minus 2 times the natural log of 3 times x. And then maybe I'll say that's equal to natural log of 4 times x. Okay. And now I'm going to push everything with an x to this side, and I'm going to factor out the x. So I've got natural log of 3 equaling 2 log 3 times x plus log of 4 times x, and then I'll factor out the x from here. I'll be left with 2 log of 3 plus a log of 4. And then I'll solve for x by dividing. Okay, so I'm going to divide log 3 by this number. It seems bad, but this is an exact answer, right? Natural log 3 divided by 2 natural log 3 plus natural log 4. Now, I will propose that a person could multiply top and bottom by 1 over natural log 3. And, that would give me 1 over 2 plus natural log 3 log base 3 of 4 up to the change of base formula. It's not necessary. And it's something we can do next year in pre-cal. I just thought I'd show you something cool that you can do. We can extend this. There are other exponential equations that we're not solving in Algebra 2, but that we can solve using these same techniques. That's what I'm trying to say here. All right, so 2f, that was enough of that. Now back to actual realistic problems that will appear on your quizzes and tests. 2f, 29 equals 4 times 3 to the x minus 31. So I need to isolate the 3 to the x, so I'm going to get rid of the 31 first, add that over here. 29 plus 31, 29 plus 1 is 30, add another 30, that would be 60, equaling 4 times 3 to the x. Okay, I'm going to need to divide 60 by 4, that would be 15. And then I'll take the log with base 3 of both sides. Okay, that'll give me x over here and log base 3 of 15. This is an exact value. All right, 2g. E to the 2x plus 1 equals 5. Okay, we're going to take the natural log of both sides to get this down out of the exponent. So the natural log of e to the 2x plus 1 is going to equal the natural log of 5. And then, okay, natural log of e to a thing is just that thing. So I'm getting 2x plus 1 equals natural log of 5. So I'm just going to solve for x the old-fashioned way, as if natural log of 5 is just some normal number that we work with all the time. So I'm going to subtract 1 from both sides. I'm going to say 2x equals negative 1 plus the natural log of 5. I always like to put those numbers that I'm adding or subtracting in front of the log, because it's very tempting for students, especially who are coming across logarithms for the first time, to say natural log of 5 minus 1 and turn that into natural log 4. And that's not something that you can do. That would be illegal algebra. Okay, I'm going to solve for x, and I'll divide everything by 2. So maybe I'll just write it like this, and divide it all by 2, like that. And that's going to be an exact value. Okay, 2h. 5 plus 10 to the x equals 25. Okay, so I'm going to access the 10 to the x first by subtracting 5 from both sides. Okay. 10 to the x equals 20 is not 2. I need to take the log of both sides, the common log, the base 10 log. Okay. Log base 10 of 10 to the x, that's going to be x. X equals the common log, the log base 10 of 20. Whoops. All right. To I. That's not going to fit. New sheet. E to the x squared minus 3x minus 40 equals 1. I was like, what is going to happen? This is not going to be factorable. Okay, but I see what's going to happen. Maybe you just look at this and you say, okay, e to the 0 power is 1, so I need x squared minus 3x minus 40 to equal 0. Maybe that's the case. But if not, if you don't just immediately see that, we're going to do what we always do, take the natural log of both sides to get this down out of the exponent. So the natural log of e to the x squared minus 3x minus 40 equals the natural log of 1. And you need to know the natural log of 1 is 0 because, you know, really I could rewrite natural log of 1 as natural log of e to the 0. That's what I tell people to do in my calculus class. There's very few natural logs we have to evaluate, but we have to evaluate stuff like natural log of 1, natural log of e to the 6, things like that. I always say just write it as a power of e. Okay, it's a power of e, right? And so I always ask the calculus students, they're like, yeah, it's e to the 0. I'm like, okay, do that. And it should be obvious. Varying degrees of success. Over here, you know, I'm going to say that this is just x squared minus 3x minus 40, and that's going to be equal to the natural log of e to the 0, and that's just going to be 0. And now it's already set to 0. I'm just going to try to factor this. What are two numbers that multiply to negative 40 while adding to negative 3? I think it's going to be 8 and 5. So negative 8, positive 5. So x minus 8 times x plus 5 equals 0. And then I'll say, all right, either x equals 8 or x equals 5. And because in the original equation, there's nobody taking a log anywhere, I don't really have to worry about extraneous solutions. Both of these are going to work. I may have said it, but I did not write that x needed to equal negative 5 here, right? If x plus 5 equals 0, that would only be when x is negative 5. All right, one more, 2j. One more of these exact value equations. But then it's going to get a little shorter. There's only 11 equations left to solve after that. So 9 to the x equals 4. This one will be pretty quick. I'm going to take the log base 9 of both sides. Okay, that's going to be x, and that's log base 9 of 4. Okay. On number three, we're going to use the table of logs to approximate the solutions to the equations. And I think I'm going to switch up how I'm presenting my work here. Get one of these few scraps of this. All right. So I'm going to try to get the tables in here also. So maybe the tables could go underneath my face. And okay, that's number 4, so let's cover that up for now. All right, yeah, sure. All right, so 3a. So in the picture, yeah, now we're good. All right, e to the 2x equals 9. So I'm going to take the natural log of both sides. Okay, so that's giving me 2x equals natural log of 9 is 2.2. It's going to be x equaling 1.1. All right, for 3b, I've got 2e to the x minus 1 plus 2 equals 20. Okay, so I need to isolate the exponential so I can take the log of both sides. So I'm going to subtract 2, divide by 2, take the natural log of both sides. Yeah, I just looked up the natural log of 9, that was 2.2. So I've got x minus 1 equals 2.2. I'll add 1 to both sides and I'll get x equals 3.2. All right, for 3c, I've got 12 minus 5 to the x equals 5. All right, so I'm going to start by taking subtracting 12 from both sides, trying to isolate that 5 to the x, but it's like, wait, this isn't an e to the thing, so how am I going to do this? I'll show you how. I think we did this on the homework or on the quiz last time, but never a bad time to remind you. The negative of 5 to the x will equal negative 7, because 5 minus 12 is negative 7. If that's true, then that means that 5 to the x equals positive 7. And so I'm going to take the log base 5 of both sides, and I'll get x equals log base 5 of 7. But it's like, how am I going to look this up with a table of natural logs? I'm going to have to use the change of base formula. And I can force you into using the change of base formula. I don't have to just hand you a scientific calculator. Do something like this. So natural log of 7 divided by natural log of 5, 1.9 over 1.6. So that's like 19 over 16. That'll be a decent approximation. All right, let's see. All right, let's do 3D. Yeah. Wait, no. There. 3D. E to the x minus 2x equals 20. How's this going to work? Oh, okay, okay, because it was 3.0. Okay, we're just going to assume that's 3. Okay, so I'm going to take the natural log of both sides. Okay. So I'd say, all right, that's x squared minus 2x is approximately equal to 3. And then I'm going to multiple powers of x, got to set it to 0. Hope to solve by factoring. Yes, I can think of two numbers that multiply to negative 3 and add to negative 2. That would be negative 3 and positive 1. So I'm going to say x minus 3 times x plus 1 equals 0. And that gives me either x equals 3 or x equals negative 1. There's nothing wrong here with, yeah, there's nothing wrong with us, you know, there's no log here. So I don't have to worry about taking the log of a negative number. That's what I would need to worry about in this situation. So I'm not going to worry. All right, e, 4 to the x equals 10. Okay, this is another one we're going to have to use the change base formula. But this time maybe it won't be as much of a surprise. So 4 to the x equals 10. I'm going to take the log with base 4 of both sides. Okay. And this is x equaling log base 4 of 10, which to write in terms of natural logs, I'm going to have to write, you know, change base formula, natural log 10 divided by natural log 4. That would be 2.3 over 1.4, 23 over 14. Two more of these, and then just a few more. So for E, for F, I already did E. 3f. 1 plus 2 times 3 to the x equals 15. So I'm going to subtract 1. Divide in half. Take the log with base 3 of both sides. And then, what am I doing here? Okay, so x equals log base 3 of 7, which I'm going to approximate, use the change of base, natural log 7 by natural log 3, 1.9 over 1.1, that's 19 over 11. One more of these, that's going to be 3g. All right, e to the 2x equals natural log 3. Oh man, I was kind of proud of myself when I thought of this one. Okay, on this, we're just going to take this on faith, and we're just going to keep going and hope for the best, right? That's all you can do when you don't know what else to do. So I've got the exponential isolated. I'm going to take the natural log of both sides. So I've got natural log of e to the 2x equals natural log 3 is just a number. So there we go. And wait a second. That was not supposed to happen. Why? Hold on a second. I had a plan for this one. I'm not seeing it now. Oh, what a shame. I am realizing I got ahead of myself, and what I meant to do was natural log of 20. So, because then that ends up being natural log of 3. So I'm going to change the problem and encourage you to do the same. I'm sure everyone's going to be asking me about that a couple days from now, but it'll be all right. That's what happens when you hurriedly make the homework assignment. Sometimes you put the wrong number in. All right, so natural log of natural log 20. This will work. Okay, so this is 2x equaling natural log of 20, x being half of the natural log of 20. Okay, natural log of 20 is like 3.0 we're seeing on the table, so I'm going to go over to... Okay, that'd be half of 1.1, it would be 0.55. Okay, that was unfortunate, but it happens, right? We all make our errors. So we're going to use the table of values for e to the x right here to approximate the solutions to the equations. All right. So for a, I've just got a natural log equaling 3, so I'm going to say, all right, take e to both sides power. E to the natural log of 2x plus 4 all divided by 5 is going to equal, pardon me, equals e to the natural log, equals e to the 3. I've solved too many exponential and log equations today, and they're starting to all diverge. Okay, so e to the 3, I looked that up from the table. That's 20.1. 2x plus 4 divided by 5 equals 20.1. Okay, so if I multiply 20.1 by 5, I'd have 20 times 5 is 100 plus 0.1 times 5. It would be 100.5. And then that's 2x plus 4. If I subtract 4, I'd have 2x equals 96.5. Well, half of 96 is 48, and half of a half is a quarter, so I'm thinking x is going to be 48 and 25 cents. Okay, that was a lot, but I think you'll be glad we worked that problem together, I don't know, at some point. So b is half of the natural log. I'm not going to be able to fit that on this slip. That's just not going to happen. So start over with a new slip of paper. Right. So half of the log of x minus 3. So I'm going to combine these, and so I'm going to start by writing it as a power, square root of x plus 3 minus the natural log of x equals 0. I think I saw this one, put it on the homework, and intended to take it off, but then forgot. Oh, well, this one I'll say kind of like this one and that one. These are not ones you should expect to see on the quiz or the test. These are just ones to really push you on the homework and you're practicing for your own benefit. All right, so I'm going to go over here, and I'm going to combine these into a single natural log, square root x plus 3 divided by x. That's going to equal 0. All right. Now, that's natural log has base e. So this means if I take e to both sides power, I'll get, I don't want to write, well, maybe I could do this. E to the this equals e to the that. Okay, I love that algebraically, but, you know, it works. So square root of x plus 3 divided by x is equal to e to the 0, which is 1. So I'm going to multiply both sides by x. I do remember. I decided I was going to leave this on there because it uses what we did in the last unit, right? And you know I love those type of problems. So I'm going to square both sides of this equation. And then I set to 0. Like, why? I copied this out of a textbook. Why would this not be 2x? Then it would be factorable. Okay, because I can't think of any numbers that multiply to -3 and add to -1, so I'm going to use a quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c, so that's plus 12 all over 2a. Now, I'm a little concerned about the negative. Well, yeah, okay. 1 minus the square root of 13 divided by 2, that's a negative number, and that's going to be bad news. So I know that the minus is an extraneous solution, and x is 1 plus the square root of 13 all divided by 2. Okay, that's going to be the only solution to that equation. All right, that was b. 2 more. Okay, the last 2 are actually going to be significantly easier. Wait, I feel like I solved that. Yeah, that didn't need the tables, I guess. I had to solve a quadratic. I use a quadratic formula anyway. So. kind of a bust. Anyway, natural log of x plus 4 minus 3 equals 2. Access the log by adding 3 to both sides. Natural log of x plus 4 is going to equal 5. I'm going to take e to both sides power, so that'll give me x plus 4 equals e to the 5. E to the 5, I looked that up from the table, and that's 148. Subtract 4, and I get x is 144. That was more like it. Okay, and then in part D, I've got natural log of 2x plus 3 equals 5. All right, and so I've already got my access I need. I just need to take e to both sides power, so 2x plus 3 equals e to the 5, which we're saying is approximately equal to 148. So I'm going to subtract 3. I get 2x equals 145. Divide by 2. Well, 140 divided by 2 would be 70, and 5 divided by 2 is 2.5. Okay, so I get x equals 72.5. Is that it? Yes. That's going to be all the problems for this video. Thanks for watching. Hope it helped. If you're still not feeling good after working all of these equations, I would highly encourage you to consider working the extra practice. Okay. It's just a long list of exponential and log equations that you could continue practicing on, and I think if you did that, that would help you feel a little more confident. All right, that's all I got. Thanks for watching.